welcome back. Just right out the gate, this is a 1.1 install I've kludged together. Don't even bother asking where I got all the elements from because they're from everything and everywhere and in of date and out of date, from the future and from the past. So don't bother asking. I'm just created this environment to test my kOS script because I want an environment that doesn't look terrible, that won't crash every revert or two, which is kind of what I run into with my my 1.0.5 installs that look nice and have a decent number of parts. That's why I'm using this setup for this. So I'm just using this setup for developing and kind of testing out my kOS script. And right now it's super crude. I've never written a kOS script, but the language has definitely advanced substantially since I last used it. So switch to 0. So that goes to the master, like it's a shared file. It's in your ships folder, and I've already set up a script there. This one, I'll post it. And if you want to follow, like the reason I'm making this video is because I want people to see what I have done of this program, as I develop it. Because if somebody else has something vastly superior, I'd love them to share it, or I'd love them to point me to where it's already shared. Because I'd rather not, create all this from scratch. But at the same time, if nobody has done something similar, then I'd love other people to be able to kind of fork what I have at any point. Actually, that's not a bad idea. Maybe I should post it to GitHub instead of just to Dropbox. But anyway, so if you want to use the program that I'll be posting, probably I'll just first drop it to Dropbox just for this, and then maybe move a link to GitHub just so it's more easily shareable and forkable there. But you'll take the script that I'm referencing here, put it in a folder called script in your ships folder, same place that you have your VAB folder, and just place it in there. It might rely on some other libraries, and if it spits an error out like that, let me know, and I'll let you know where I found those libraries. But really, I just grabbed a bunch of existing kOS libraries that I don't know anything about, and I might be using some of them, like probably the PID library. Anyway, so switch to 0, so the master file. So that means it's like a global file. So where this script is, any of my craft can access it. Where, in contrast, where a kOS script starts out is in a local folder just for that craft. So those kOS scripts would be just associated with this craft. So run launch3.ks. And so every line ends with a dot. That's just how you terminate a line in kOS. It's weird to me, but I'm not like a super lingual programmer. And so this script is pretty much just refined from a script that BevoLJ used for one of his videos. It's kind of removed all the elements I didn't need or modified them. So like messages like booster ignited or the countdown time are adapted from his script, so are really just from his script with slight modifications. And so it goes through a number of phases, and I'd like to get it down to like 2 main phases, but there's always going to be like these early phases, like straight up boost, and then the code has a line where it says, okay, once you hit this speed, go to start your turn, start the gravity turn. Now, from what I can see, the gravity turn, how it follows, doesn't have an equation directly, so it doesn't have a way to compare straight to your prograde, your surface prograde, which will probably be important so that you hold, your dynamic pressure doesn't give you trouble. Because my goal here, sorry, I'm only stating it a few minutes into the video, I want to make first a kOS script that can launch any vehicle into orbit. Not necessarily efficiently, that's going to be a weakness starting out, but I want to be able to launch, developing a kOS script that can launch anything, any craft into orbit at all, just orbit period, but any craft is the first goal. So right now I'm using a piecewise function, as you'll see in the code, same as Bevo did, and I've seen that in other kind of launch computers. So it's piecewise in that it kind of has these little segments where it says, like, if you're within this loop of, if you're within this velocity range, then you need to, sorry, just reducing the plume a little bit if I can, so slowing down just a little bit. Sorry, if you're in this velocity range, so that's why you'll see, so it says mode set turn, and then later on I'll point out a different measurement. It goes through these different modes. Once you're at a different velocity range, it looks at time to apo, and I also want it later to look at vertical speed as well. And that's how it determines what pitch it should have. And early on here, it's either just a specific set angle or it's following this kind of gravity turn function, which I kind of want to throw a normalizing, another function on top of that to make it depend on other things. But anyway, it's going to kind of have planned out some of the functions I want to throw in. So it says fin mode 2 here, so it's going to be, I believe it's moving towards set angles based on how far away from apo we are. So with this specific craft, this Atlas, you need to drop that. I found this is a fairly reliable, easy craft I can make use of for this testing, because even as I evolve this program, I can really change how this craft flies by just choosing when I drop that. And so in this case, I dropped it a little later than I usually do, actually fairly close to one of the historical times where the Atlas would drop the booster stage cutout. But yeah, it's a pretty looking environment. A bunch of mods are kind of in testy modes for KSP 1.1, and I've had good stability with them, so I'm just using this as kind of an easy, pretty place to develop my kOS script. So yeah, the program goes through these different finishing modes, and it transitions through these currently as a stepwise function where it's just looking if the surface velocity is in a certain range, then it kicks into that mode, or that fin mode as I've labeled it here. I could have it reading out a ton of other stuff, like there's other stuff that I do want it to use in the background. It's just, some of this was already part of BevoScript, and other parts are just for debugging. So this craft will get to orbit, and as it does, I'll point out some of the weaknesses of the program as it stands. So there, you see it moved to another fin mode, 2.5, because I didn't leave enough indexes. I realized I needed another one. So it's kicked down, so it noticed that the time, so it switched to another speed mode. It got to a certain speed, and it realized the time to apo was outside of a range, so it needs to pitch down to bring this time down until that range is satisfied. And the thing I don't like about the stepwise functions is what you saw right there. It pitched down just once. It makes that judgment every loop, so a couple times a second, where it's looking at this number and it's checking this. But these are discrete outputs. The pitch is -15 or it's -5, etc. So these it's making these judgments in these quick time cycles, like like a PID would, or just a program. It keeps running through the program as quickly as it can. But these actual outputs are discrete outputs. It's either -15 degrees, 5 degrees, or 1 degree, depending on what it sees as this time. And I want continuous functions, maybe a couple continuous functions. I'd like basically the output of my function to be what the pitch should be, and the input to be everything else. The input to be time to apo, what is our current velocity, etc. So that was actually a way smoother cutout than I usually get. And see, I still had oh, did it run out of fuel? Did it run out of fuel? Oh, it totally ran out of fuel. Wow, interesting. So I cut out the engine a little late there. It looks like it ran out of liquid oxygen, but I'm actually in orbit. So right now it can get a few different craft into orbit, my program, but it's not flexible enough to get everything into orbit. It requires me to do manual staging for everything beyond that initial stage, which I do want to make it optional, that it has these kind of easy, obvious, it does obvious staging. Lots of functions I'd like to add into it like that, but right now manual staging is good for kind of my work and development flow of it. But yeah, it placed itself in orbit, no real trouble here. I didn't get to select the orbital altitudes at all. But again, I do want to make that selectable as well. So I want that to be one of the inputs of the program. Kind of my version 1.0 of this program will let you tell it what altitude you want it to end at, ideally as a circular orbit. So I can say 200 kilometer or 300 kilometer orbit. It won't be smart enough to tell you don't have enough delta V to get there or not, because I don't know, I don't need a program to tell me that, right? It's my job to design the craft right. But I want to be able to target that orbit, and that orbit. And that's why I need slight tweaks in the gravity turn, so I can target specific orbits in an automatic fashion rather than manually. But yeah, see, as you can see, it was successful. I don't think I'm going to show it launching with some of the other vehicles, but some other vehicles I've tested it with are like a Titan 3C, so two solid boosters at the beginning, and then basically a Titan 2 strapped in the middle of that. With I think just a generic payload, maybe a trans stage, something like that. So that's like a 4-stage vehicle, but it worked. It was able to follow that. So I might do another video maybe with one of those launching where I discuss some of the other aspects of how I have the program set up. But right now it's a great bare bones tool, I believe, or for me now. It's pretty much just stripped down to what are the necessary little bits, the raw elements needed for this program to function successfully. And I'm going to be improving it. So the next thing that I currently have on the docket for improving this program, which has been on my docket for a couple weeks, I just haven't had the time, is to go from that piecewise function where the pitch is just our discrete outputs, where it just makes a discrete logic judgment and says, okay, that means the pitch should be -15 or -5 or be 0 or 5, etc. I want those to be continuous functions. So pitch is the output, and all those other factors go in as linear inputs. So it's fed in the speed, it's fed in time to apo, whatever other values I can derive, and it outputs that pitch. So the pitch won't just only be -5 or only be 0. If it finds, okay, it doesn't need to be -5 anymore, it'll come up with an answer, a desired pitch that is between 0 and 5, -5 and 0. There might be unintended consequences of that. I haven't set up the program to do it yet, of course. I am completely inexperienced with kOS, so thank you, Bevo, for providing that script that I kind of started this from, but he said free to use it. So I've heavily modified his script so that it just can place a wide range of craft into orbit. You're also free to use the script that I post, modify it, whatever you like. I'd appreciate if you share or link so that I can also see what modifications you make, because people have probably made way better scripts than this for kOS than this one as I have it now. But if I'm incorrect about that, or if I'm just trying to do something different than what anybody else has tried to do and is still around in the community, I want other people to share in that program, right? If it's a good starting point for you to learn kOS, or just load up the program, load up a Mercury Atlas like this and just watch how it ticks, Look at the code. That's why I put the fin modes as outputs, so you can kind of see, you have a visual way here to see for what's happening behind the scenes with the code, like when it's actually in each mode. And I find when you're writing the code, or even later, for it to be a bit verbose like that, where it kind of spits out things here to let you know what logic mode it's in, which bit of the code is it now trapped in and operating on. But yeah, it's able to get this into orbit no trouble, which is awesome. So my 1.0 version, my goal is to be able to target an orbit, possibly not efficiently, and I'll talk about what things will let me go to like a 1.1 version, or my final goal, which I would maybe consider a 2.0, would be a kOS program that can launch to an efficient rendezvous with another craft. Because ultimately that's what I want to automate. I want to be able to use like Titan type stages, Titan 3, to be able to launch and do on-orbit construction. So I can launch these craft and build up a craft in orbit without a whole bunch of trouble of timing the orbit and precisely flying into a matching rendezvous compatible orbit with another craft, because that can be really tricky to get right. There's like a lot of little things you can get wrong that really make that a big pain in the butt. I'd rather just be able to automate a launch to the same orbit, so it kind of finds the time and such. But anyway, thanks for watching. I hope you found it informative, useful. Feel free to use the kOS script. If you have any questions of how to use kOS scripts, you can go ahead and look at the KSP forum for that, because, like I said, by no means any authority or expert on kOS. I've literally never even written a functioning program from scratch. With my programming style, it's just better to learn by seeing something else that functions and then modify it, and then eventually start replacing chunks of it like I'm doing now with this. So thanks for watching. Goodbye.